Okay, hello. So we were in our triangle intersection. So we found out that the triangle, triangle T1 first tested to intersection with the plane 2. And that's how we find out that by the determinants, and the determinants have different signs is the possible thing that C. So in case that in A case occurs when all three vertices of T1 lie on the same open half space introduced by P2, plane 2. In this case, no further computation is needed since there can be no intersection, because this T1 doesn't intersect even the plane 2. Case B occurs when both triangles are coplanar and defined at the same plane. This special case is solved by two-dimensional triangle intersection. So on those planes are in the same position. And in case C happens when the vertices T1 lie on different sides of the plane 2, and T1 surely intersects the plane 2. In this case, should be checked in the next step whether T2 intersects plane 1 in the same manner. So then we change just those plane coordinates. Those triangle coordinates and the plane coordinate. And then when we have found out that they intersect, then possible intersection line L should be calculated. Then, and intersection of those two planes are called L, and that's how we get a normal vector, with those two normal vectors and their perpendicular vector v, which is shown here, is that a line vector. And so on, we find that line, and then we have to find those I, K, L and J by that line. And when we have find those points, then we know that if how this triangle are intersect the other triangle. Okay, then we have the intersection between rays and the lines are calculated. How that might be, let's take ray line collision, don't save. And here I have an example too, but the purpose is that the definition is that when this d, which is the distance vector, which is a perpendicular for both of vectors, it's the closest line, closest vector between closest segment in fact between those lines. When it is a zero vector, then and the segment is 0, then they are intersect. And there is a second point for that this scalar which is pointed from that ray, it have to be also positive, because it is possible that that line is in that vector, but it is over here example, but in the same line, so the intersection point would be over here, but it is not in a ray. Okay, so how we can do that? Let's find out this point first. This point GU P, and we are taking that as a line, that ray also, but they intersect D, a 0 vector, and T is positive. And I have an example case over here where L is 1, -1, -2. This is a point where the one point in a vector, in a line, and there is a vector which have a scalar over there, A, and then there is a ray with starting point origin is in that point, in that dimension, and then there is a vector will have a scalar, and remember that this should be positive if they intersect. Okay, how we find it? First we put those make line L x vector, y vector, and z vector, and then there is a ray for ray those x, y, and z made 2. Then we find the x, y by this formula when line minus ray, and so forth. We have do a minus thing by this line minus this line. This also could be possible to do other way, but I choose this kind of way. And then we find those vectors over there, and by that case, if this is a 0 vector, then and t is a positive, then they intersect. So let's find out what kind of that would be. The D is a perpendicular to both L and R at the same time, then D is the closest distance. So D dot V, eli D dot D dot N should be 0, and the same position D dot V is the 0 too. Then I calculate those dot products and find out that we have this kind of formula for find out how this works, and then we find out that we have this kind of formula in case 2. By solving these two, we can find out that the only possible scalars should be 5 2.5, and then the t is 1. So we find out that t could be is 1, it is positive, so there could be intersect, but because the vector isn't a 0 vector when we put those in that case, then we know that the distance of those two, this ray and line, is square root 13.5. Then we know that there is no intersection. Section. Okay. Then that was all. Thank you and goodbye.